welcome to another video. Hope you're ready to flex those brain muscles. Today we're going to talk about quadratic functions and how to find the vertex of a quadratic function. So there are two main ways we do this. Either we can convert a quadratic function into vertex form, which we'll do in the next video, or we can use this little trick, right? But in order to use this trick, we have to have a quadratic function that's in standard form. So ax squared plus bx plus c. If it looks like this, then we can use this little trick. So before we talk about this trick and how to do this, let's make sure we know what a vertex is. So when we have quadratic functions, these, when we graph them, they are parabolas, right? Basically a U shape. And there are two possibilities. Either we have a U shape that opens upward, or we have a parabola that opens downward. So these are the two possibilities. This case happens when a, right, our leading coefficient, is greater than 0, and this case happens when our leading coefficient is less than 0, okay? So in this case, we'll actually have a parabola that opens upward. So what is the vertex? Well, first of all, we can recognize that parabolas, right, these U shapes, they are symmetrical. We could draw a line on both of these, a vertical line, that we can reflect across this line, and it would be the same thing, reflecting it, right? They're symmetrical. And this line is actually called the axis of symmetry, okay? These lines are not perfect, I apologize. But yeah, the line I could draw through where if I reflect it over, it's the same thing, right, on both sides. That is the axis of symmetry. And where this line intersects with our graph, with our parabola, that is the vertex, so both of these points. So that's one way to think about what a vertex is. It's where the graph, it's where the parabola for the function intersects with the axis of symmetry. That's one way to think about it. Another way to think about it is it has to do with range, right? Think about the y values. So when we open upward, when we have a parabola that opens upward, the vertex is our least y value. Basically, it's the lower bound for the range, right? My domain is all real numbers. My range is from that vertex point all the way up to infinity. And we can say a similar thing about this, but in this case, this is an upper bound for the range, right? This is my greatest y value. So the y values are bounded here, and they go from negative infinity all the way up to whatever that y value is, right? I could draw over to the y-axis, and whatever that value is, that's my upper bound for the range. So that's another way to think about it. A third way to even think about it is you start from this point and you draw your u. That's usually what I do when I draw these in the first place, is I do something like this. So that point that you start from, right? And you kind of open up from that point, or open down from that point, if you want to think about it that way. And again, these aren't strict definitions, but hopefully you get the idea of what a vertex is from this. So let's go and use this trick to find the vertex. And what we can do when we have something in this form is we can simply say the vertex, which is a point, by the way, right? So it's going to be coordinates, x and y coordinates. It's going to be an ordered pair. And what it is it's negative b over 2a, right? So my b is, in this case, my b is negative 2, and my a is 1. And this is actually going to be f of negative b over 2a. And what that means is I find negative b over 2a, and that's my x coordinate for the vertex. And how do I find the y coordinate? Well, I have the x coordinate, and I have the function. So to find the corresponding y coordinate, I can just plug in this x to get out that y. And that's why this is f of negative b over 2a. In this case, we have a y, but it's a function, so we could replace that with f of x, and that's the same thing. Basically, we find this negative b over 2a, and that's the x value for our vertex. That's the x coordinate. We go and plug it back in to find our y. So let's go ahead and try this out. Negative b over 2a. In this case, we said b was negative 2. So negative 2 is just 2 over 2 times 1, which is 2, which equals 1. So our x coordinate is 1. And now what I do? Well, I go and plug 1 back in, and I have what? Let's see, 1 squared minus 2 times 1, that's 2, minus 8. So I have 1 minus 2 minus 8. That gives me negative 9. So my vertex, written as an ordered pair, is 1, negative 9. Okay, so this is actually pretty simple. If we break this down, it's just 3 steps. The first step, we just make sure it's in standard form, right? right? If it's in standard form, we're good to go, which is, again, ax squared plus bx plus c. If it's in that form, we're good to go. Then we just use this negative b over 2a to find the x coordinate of the vertex. Once we have the x, how do we find the y? Well, we have the function, and we have an x value, so we can just plug in that x value to find the y, and that's exactly what we do, is we plug in that to find the y coordinate, and so our solution is this x and this y listed as an ordered pair. Alright, so let's use those steps I just broke down to find the vertex of this quadratic function. So first of all, we need to make sure that it's in standard form. It's almost always going to be in standard form, but you can double check just to make sure. In this case it is. Now what do? Well, we just find negative b over 2a, right? So what is my negative b over 2a in this case? And remember, this is the x coordinate for my vertex. So this equals what? Negative 12, because my b is 12, over 2 times negative 3. That's negative 6, right? 2a, my a is negative 3, that's negative 6. So this equals what? Well, a negative divided by a negative is positive, and 12 over 6 is 2, right? This simplifies to 2. So my x coordinate is 2. So in my answer, I'm going to have vertex, and remember, it's going to be written as an ordered pair. My x is 2. So how do I find my y? Well, remember, I can plug in for x. I have the function, I have the x value. All I need to do is find the y. So I just plug in for x. So let me go ahead and write out the full steps for this. I have negative 3 times 2 squared plus 12 times 2 minus 10. So we just need to be careful with our algebra. I'm going to do this exponent first. That becomes what? 2 times 2, 2 times itself, right? That's 4 times negative 3. That's negative 12. And then plus what? 12 times 2, that's 24. Minus 10. So this is now what? Negative 22 plus 24. This equals 2. Okay? So, what is my vertex? 2, 2. Okay, and I'll make a separate video on this, but just to quickly note, we can use the vertex, and we can use the fact that we know that it opens down, since the a is negative, right? The leading coefficient is negative. We can use both these facts to sketch a graph of this, right? Think about it. If our vertex is at 2, 2, we can go up to 2, 2, plot a point there. We know that this opens down, so it does something like this. So then we know how many zeros it has as well. We know it for sure has 2 zeros, so we don't even need to use the discriminant. So we know that this can be either factored, or we can use the quadratic formula and find those zeros. And if we plot those points, and we can just draw our U-shape, right, our parabola through those points, then we're good to go. That's a good sketched graph of this quadratic. But we'll do that more in another video. Alright, last example, and it's a little tricky only because we're missing an x term in this case. So what does that mean? Well, it's hard to identify our b when we don't have that x term, but look what we can do. 2x squared plus 0x plus 5. Isn't this the same thing? 0 times x, that disappears. So really this is still a quadratic function, but our b is 0, right? So since our b is 0, what do you think our negative b over 2a is going to equal? It doesn't even really matter what a is. B is 0, so this just equals 0, right? So what do? Well, we plug 0 back in. This doesn't mean we don't have a vertex, or it doesn't mean our vertex is 0, 0. We have to plug this back in and see what happens. So I go ahead and plug 0 back in for x, and I get 0 squared times 2, that's 0, right? Plus 5. So my solution for the vertex, we know that my x coordinate is 0, and when I plug that back in, I got that my y coordinate is 5. So again, this still works even when you're missing an x term, and this is still a quadratic function, but in this case, the b is 0. So it actually makes it a little bit easier because you can just plug 0 back in. So hopefully this video helped. If you have questions, please leave those below. If you enjoyed this video, hit like, hit subscribe. If you need more help, check out my other videos, and keep flexing those brain muscles. Let's make some brain gains.